class. So welcome back after a long winter break that we had, and I'm sure all of you are doing well. So I'll be resuming from where we had left off with a discussion with regards to operating system. Now before I begin with the new chapter, I just want you to have a look at what I'm going to present to you right now and what do you think these are. So the first picture I've put up in front of you, and if you're not sure what is this, I'll just show you another one, and again if you're not sure, I'll show you another picture, and still if you're not sure what these are, let me show you a final picture. Now if you have guessed it right, okay, I congratulate you, and for those who have not, so get an idea what these are. Okay, these are nothing but the different kind of files that you have been storing and opening and referring from your computer system, from your laptop, or even for that matter from your mobile phone. So these are nothing but files, and one of the key role that the operating system usually does, okay, when it comes to management of resources is management of files. So the chapter that I'm going to talk about now is on files, and these are the summary. Okay, so we'll be talking about the file system, for which here we'll be talking about a different kind of file information being retained, okay, and that is in the form of the files that you've been familiar with. And then we have seen that we can also maintain different kind of files, especially which are in the form of storing a collection of files, which we refer to them as directories. Then we'll see that how in a particular operating system design, what kind of file system implementation is being employed, and then what are the different file systems. Okay, so if you have seen in almost every computer application that you've been working, whether it's a gaming application or a text application, a text management application, or an image processing application, you'll see that each of these applications require that these information, okay, that you are manipulating or managing through such computer applications, need to store them and retrieve them for future references. So whenever you've seen that when you run any user application, its running representation of it, called a process, is always in action, and in such a scenario it will also require to store a limited information about it in its own address space. Now if you're going to see in the virtual address space, okay, of the you can say computer system, the storage capacity is often restricted. For example, for certain application this size might be adequate, but for some it'll be very, very small, and such applications such as banking or corporate record keeping, it is required that a large storage facility has to be there. And a second problem with keeping information only in the process address space is that whenever that user process terminates, that means that every time you close that application, the information being stored in that address space is lost. So there's a need that some kind of a mechanism has to be there to store those information on a permanent basis. Okay, and seeing that if you depend on the address space of the process to store those information, and seeing that when you terminate such process, okay, having those information being retained to simply vanish is not acceptable, and also it must not go away even when your computer crashes or when you reset your computer. And another thing is that if we store information in the process address space, you'll see that there will be multiple processes that will be running at the same time in your computer system, and these will be accessing the information or parts of it at the same time. So there's a need that these information are to be stored on a permanent basis. So for that, some kind of a mechanism is needed, and that mechanism is called a file system. And with file system, it provides you the ability to store information on a long-term basis, so that information are stored first of all in large amount of large volume, and second, you can still access those information even during the termination of the process. That means that the information will be stored, and whenever you run that process again, you can still access it. And also multiple processes can have the ability to access the information concurrently. Okay, now the usual solution that is being incorporated in an operating system is to store this information on disk and other external media in units called files. Okay, and we have to ensure that information stored in files must be persistent, that is, it should not be affected by process creation and termination. Okay, and that part of the operating system that looks into the management of files is known as a file system. Okay, now from a user point of view, the most important aspect of a file system is that it should be able to show to us how does the file, okay, that is being stored in a computer system looks like, okay, and what kind of a file it is. Does it represent a text file? Does it represent an audio file, an image file, a video file, or it could be an executable file, okay, that represents the running representation of a software. Then how are files being identified in terms of naming them, and how do you protect them? Okay, by protection it means that does it has the ability only where you can only read its content but you cannot modify, or you have the ability to do both. Okay, and also it has to also see that the file system should have some kind of operations that will allow us to operate and access those such files. Okay, now as far as file naming is concerned, you might have come across all these different type of files, and the naming convention being followed is that it is made of two parts. First of all is the primary file name. The primary file name often appears on the left hand side and of the full stop, and the file extension usually appears after the full stop, okay, or the dot. Okay, so in this case this is a file represent a backup file. This is a file that represents a C file. So you'll see that file extension usually have a 3-letter word representation. Okay, now when you're naming files, it is basically an abstraction mechanism that will help a user to know, okay, this file, it contains this kind of information. Okay, and it will also tell us, okay, what kind of information are being stored in it. Okay, so that when you read it back, you can know that, okay, this is what it's going to contain. And you'll see that the most important characteristics of any abstraction mechanism is the way objects being managed are named. So in a file system also, in order to manage these files properly, proper naming of those files is required. Now whenever a process creates a file, it gives a name to that file, and when the process terminates, that file continue exists with its name that was given during its creation. Now as far as the naming rules is concerned, it varies from one operating system to another, but usually almost every current operating system allows strings of 1 to 8 letters as legal primary file names. Okay, and some operating system also distinguish between uppercase and lowercase letters, whereas others do not. As far as Unix is concerned, it falls under the former, where if you give one particular file name and another a particular file name, okay, but the name is the same but the cases are different. For example, suppose in Unix, okay, suppose in Unix, if I have a file called file1.txt, okay, now this first file is written in small letter and the other one is written in capital letter, file.txt. Now if you're going to see for Unix, you will recognize that this file is a different file name from this one, though the spelling of the file names are the same. But in operating system like MS-DOS, Windows, it does not differentiate between files that are having the same name but cases are different. It's treated as the same file. Okay. Now almost every operating system support a two-part file names with the two parts separated by a period or full stop. Now the part following the period is called a file extension, and the part before the period is called the primary file name. And this file extension usually indicates something about the file. Now in MS-DOS, file names are usually 1 to 8 characters long plus an optional extension of 1 to 3 characters long. In Unix, The size of the extension, if any is there, is up to the user, and a file may even have 2 or more extension, okay, in it. For example, let's take this one. Let's take this file name, which I'll highlight now. Look at this file, proc.c.z. Now this is an indicator that, okay, this is a file whose primary file name or its file name is being referred as proc.c.z, where it says that this .z is commonly used to indicate the C file which has been compressed using the Ziff-Lamber compression algorithm. Okay. Now in some systems, especially in Unix, file extensions are just convention and they are not being enforced by the operating system. But in Windows, file extension is being enforced strictly. Okay, that means that, okay, in Unix, if I have a file name called file.txt, it might be some kind of text, but the name is more to remind the owner than to convey the actual information stored in it. So it may happen that this file.txt may not contain only words, English words. It may contain, you know, a programming code. Okay, so that is the meaning of that. Okay, now as far as the file structure is concerned, how files are being maintained in a computer system, it consists of 3 kinds of file structure. One is called a byte sequence, the other is called record sequence, and the other is called a tree. Okay, now in the first sequence, called the byte sequence, the file is considered as an unstructured sequence of bytes. Here the operating system does not know or care what is inside the file. All it sees that this file is made of a collection of bytes. Okay, and any meaning must be imposed by that user level program that opens that file. That means that the meaning of that file will be determined by that user program or that user application that you are using to open it. Suppose if this, you know, this file, if it's stored as a byte sequence and you're opening it through an application like Notepad, then basically it will be considered that this is a text file. Or let us say if you open this file through, let us say, Photoshop, okay, then it will say that this file is containing an image content. Okay, then the second way is the second file structure is called the record sequence. Now here a file is being stored as a sequence of fixed length record, each with some internal structure. Okay, now very important to this particular model is the read operation. Whenever it's being used to read such a file, it returns one record at a time, and the write operation simply overrides or adds some extra record in it. And at the kind of application that we use nowadays does not fall under this particular category. It's usually used especially with those that are related to databases. Okay. Then the third structure, which is the tree structure, it's basically an arrangement of a file where it consists of a tree of records. And here not necessarily all files will be of the same length. Okay, and each file will contain a key field in a fixed position in the record, and the tree will be sorted on the key field to allow rapid searching for a particular key. The basic operation is not to get the next record, but to get that particular file with a specific key. Now this kind of a structure is widely used on mainframe computers, okay, which do a lot of data processing. Okay, with personal computers we do not come across such file structure. Okay, now as far as working with files, you'll come across different types of files. Okay, some files are text in nature, some files are in audio in nature, some are in the form of video, some are in the form of an executable file, and some are in the form of an archive file or a compressed file. Okay, and each of them have a different arrangement. Now this slide that you are looking at the moment, you'll see that on the right hand side or the left hand side, okay, you'll see that it shows us the file structure of a file type, which is an .exe file, and on the right hand side is an archive file, which is usually a .rar or .zip file. Okay, now as far as the operating systems that you've been working with, whether it's Windows, Unix, they support several type of files. Okay, and the most important files that we are very well versed with and so used to are the regular files, which are usually nothing but files that contain user information. So these are nothing but files that are being created by the user, okay, through the respective application. And then besides the regular files, you also have directories. Now directories, or sometimes in Windows we call them as folders, are nothing but system files that are usually used for maintaining the structure of the file system. And usually we use directories for storing a collection of regular files within it. Okay, then you have also character special files, which are related to the input output, and these are used to model serial input output devices such as terminals, printers, modems. Okay, that means that any input that are being conveyed through the printer and terminal, okay, those information are being stored first of all in a character special file. Then you have block special files. These are usually used to model the disk, especially when you're going to access the information from the hard disk. Okay, then block special files are usually used to collate those information that you are trying to access from the hard disk. Now regular files, which are the ones that are very familiar with us regular users, are either being treated as ASCII files or binary files. Now ASCII files are nothing but files that consist lines of text, okay, which in some system each line is terminated by a carriage return character. In some it will be a line feed character, and in some system MS-DOS use both. Then you have also binary files. Now these have some internal structure that are known specific to that program that use them. For example, let's take .doc or docx files. Now these are regular files, but okay, to be able to read the content of those files, they have to be accessible only by an application like MS Word or OpenOffice. Okay, or let's take for that matter .jpg. I cannot use this file .jpg to be opened through Notepad, okay, because their internal structure is known only to that program that can understand it. Like .jpg, I can open it through Photoshop, I can open it through MS Paint, right? Okay, so this is what is meant for that. And even for an example, I can consider this presentation slide I'm showing to you right now. Okay, it's a simple executable binary file which can be accessible only by PowerPoint. Okay, now the file that you've been working with is nothing but a sequence of bytes, and operating system will only execute a file if it has that proper format. Now each and every files have regular files have 5 sections: the header, text, data, relocation bits, and symbol table. Now the header starts with a so-called magic number identifying the file as an executable file. Then comes the size of various pieces of the file, the address at which the execution starts, and some flag bits. Now following the header are the text and the data of the program itself. Now these are usually loaded into memory and relocated using relocation bits, and the symbol tables used for debugging. Okay, so this is a brief understanding about what is a file and how important it is that files are to be managed by the operating system. Now in the subsequent class that I'll be talking about, okay, we'll be looking at some more capability of features that are present with regards to management of files. Okay, and one of them is file access. Okay, and that will be discussed in the next class. Thank you.